Today we're going to talk about the independence of path. Suppose you have two piecewise smooth curves. Let's C sub 1 and C sub 2 are two piecewise smooth curves. We call these piecewise smooth curves paths. Suppose they have the same initial and terminal points. These paths have the same initial and terminal points. So initial point like A and terminal point like B. Very good. In general, we don't expect the line integral over C1 of vector function f is the same as the line integral of vector field or vector function f over C2. So in general, we don't have equality between these two. But if it is true, then we say that, hey, it is independent of path. So note that if f is continuous, it means that all of the components are continuous. F is continuous vector field with domain D, we say that the line integral is independent of path if you have equality between these two integrals. If the line integral f dot dr over C1 is the same as the line integral of f dot dr over C2. Make sure C1 and C2 have the same initial and terminal points. So A to B, suppose C1 is defined like this, and C2 is defined like this. Just curve, a smooth curve. C2. We have a theorem. So we're going to see how to connect these dots. A line integral f dot dr of f vector field f over curve C is independent of path in D if and only if the line integral over C is 0 for every closed path C in D. So let me write this guy down here. If and only if the line integral f dot dr over C is equal to 0 for every closed path C in region D. Very good. So now you have a nice condition to check to see how we can say that it's independent of path. So if it's not 0, then you're going to say that it is not independent of paths. It depends to the path.